So, how many of you are using event sourcing? Okay, cool. How many of you want to use event sourcing? Okay, great. I hope that the rest knows that I'll be talking about event sourcing today, so you're in the right room. So I need to start with a confession. Teaching event sourcing is hard. I mean, it is. So there, I said it. Now it's going to be just easier. But let's start from the beginning, so where it has started. So this is me. I have no idea about event sourcing at that time, but I was, as you can see, a huge fan of Kurt Cobain and Nirvana. And what's the most interesting is that at that age, it was 19 years ago, I created my first bank account. And let's do some math. So it was 19 years ago, if I count it well. Let's say that I was doing a 3 transaction per day during that time. And let's say that in a year, we have 365 days. Let's ignore the leap years. And that gives us 20,805 transactions. I'm not sure if that's the correct number. Sorry, I didn't check that. But let's say that I was doing 10 transactions per day, like I was extremely active, right? That gives us almost 70,000 of events during that span. And if we have 100 transactions, and I'm not so rich or poor, depending how you count it, but if you are a company, then you can easily get like 100 transactions per day. And that gives us like almost 700,000 of transactions. Okay, but why am I telling that to you? Who cares? It appears that even stores do. And why do they care? Because that's in the nature of the event sourcing. Because typically, when we are starting to explain event sourcing, we are starting with the bank account, because that's an easy example. So you are getting comment, like, for example, withdrawn some cash from ATM, or that some incoming transfer was recorded, etc. So this is nothing spectacular. It's like in a regular approach. But then the first thing that you need to do to get your state is to get all of the events, so all of the facts that were recorded. So in our case, that will be all the variety of the transactions that we had. And once we got those events, then we apply those events to get our current state, or as my friend Duncan would prefer, so state at the certain point of time. So we apply one by one, and that's easy to explain, because if we have incoming transfer, then we are increasing the balance. If we withdrawing money, then we are decreasing the balance. Easy peasy. And after that, when we perform the logic based on the state that we just rehydrated, then we need to store another event, another fact about our entity, about the process that we are making. And that's great, because as you can see, we have the granularity, we have the history, we know precisely what has happened for our domain object, which is great. We are not losing any data, because in a classical approach, if you are if you are updating the state, then you are already losing informations. But let's have a look on how event stores work. So this is event store. But this is also, surprisingly, your regular relational database, because databases internally works like that, especially event stores, because they are the databases turned upside down. So the central point of event stores is something that is called append-only log. In the traditional approach, it's called write-ahead log, transaction log, whatever. It means that when we are recording some facts and some information that happened in our system, then we are just putting them as a sequence of events. But I lied to you. That's not how event stores are built inside. Event stores are built inside more like that. So they are not like the constant, really, sequence of events. It's more like the set of sequences. we can still have the ordering guarantee on the whole system, but if we realize that, in fact, event stores are keeping those events in the same location, then we can understand why event stores are great on reading a lot of events. So if we slice our huge append-only log into smaller pieces, then we will get the streams. And streams are in event sourcing represent usually in 99% like one stream per var record in a classical approach. And I rotated a bit this previous image to show you that, in fact, event stores internally are keeping all of the events for the same stream, so for the same entity at the same place. So if you want to read all of the events from the specific stream, then it's like you be streaming the PDF file or a video file. Think like a YouTube, right? Streaming is fine. So you don't need to do additional hops just to get the events. So that's why event stores are efficient in getting a lot of events, because they are just taking some place in memory and just pushing it forward. So in fact, append-only log is the index. It just points to the specific events in the specific streams. And if we have a look on that stream, then as you see, this stream is kind of manageable. It's kind of regulated. But long streams looks more like that. And why is it important? Mikhail Shilkov, on his blog, did a nice thought experiment. He just said that reading one event or appending one event is one I/O operation. So when you are appending one event after your business logic or reading events from the stream, then if it has one event, that's one I/O. So if we have only events, one event in the stream, then we have just such a linear operation growth during time, because we are just appending one event, and that's all. If we have 10 events, then this green line is also linear, but a bit bigger, because what we are doing is that at first, when we are appending first event, then we are not reading anything because there are no events. So it's a one I/O operation. If our stream has 2 or 3, then it's much more and it's growing. So let's have a look if we have 100 events in the stream. Then things starts to get a bit more complicated. So it's still looking close to the linear, but we can see that something is going on. So this is how it exponentially grows if you have much more events. Of course, this is more like a thought experiment. This is not precise calculation, but it's just to show you that small streams are manageable, but long streams are not, even though the event store are really great at reading a lot of events. So as you can see, that can escalate pretty quickly. And getting back to my bank account and my virtual 20,000 of transactions, so the potential solution will be, OK, no worries, we'll just use snapshots, right? That's the most common advice that we can find on internet. And what are snapshots? So I explained you that to get the current state, you need to get all of the events for the stream and apply them one by one. And over here, you can just see a 5% of my stream. So when we are using snapshots, then instead of just updating the balance, as I explained you, at some point, we can decide to just take the snapshot, so the state of our aggregate, of our current state, and store it somewhere. I will explain you later on what does it mean somewhere. And from now on, we can also, after each event, store the current state somewhere as a snapshot. And then, instead of loading this whole huge stream of events, we will be just calling just some storage location to get the current state. Yeah, sounds great, right? You are just using just one call, one record. What can go wrong? And in fact, if we will be doing something like that, so after each event we will be storing new snapshot, then in fact we are doubling the amount of events that we have in our event store, and we are doubling the write operations. Does someone know who are those jolly small people? Those jolly people evolved into our president and prime minister. At some point of time in Poland, we had a twin-headed government. So, so you know, in Poland, we precisely know that double doesn't always mean double fun. So, in our case, it escalated pretty quickly. So, you know, just small snapshot, small events, yeah. They can change into twin-headed government, right? But someone may say that we are not doing like that. That's just stupid. So I'm just, you know, trying to convince you to just drop the idea of the snapshotting. And in fact, you are not doing snapshots like that. So instead of just doing the snapshot after each event, you could make the snapshot once per something. And what's something? Like, we will get to that later. So when we have this snapshot once per something, then we can load this snapshot, and we can load all of the events that happen after this snapshot was made. And thanks to that, we are using like a half event sourcing, half I don't know what. But of course, we are kind of reducing the I/O operation. But how often is enough? So can anyone tell me how often is enough, like in your systems, if you are using event sourcing, like, can you judge what would be the enough something? Like, would it be every 10 minutes, every day, maybe every 10 events, or every hour, and 100 events? So if it's 1 hour, then we are doing, but if it's shorter, but it's 100 events, then we also doing snapshots. Or maybe we can select some type of event, and right after that, we can do that. But in fact, this is like, what? This is the hope-driven design. Because we are just hoping that we are right, that we can predict how often we should be doing those snapshots. Like every 10 minutes could be fine, like we know that we have steady traffic, steady move on our site, but you know, Black Friday comes and we're doomed. Maybe every 10 events, also Black Friday comes and we have like hell a lot of snapshots because we have hell a lot of transactions. And usually that time when we see that issue is when we are already doomed, and that is the most important time for our business case. Like there is nothing more important than Black Friday in e-commerce. So yeah. Let's also discuss where we can store snapshots. So maybe we could store snapshots in the same stream. That's kind of tempting idea because we are just storing event and also snapshot, same transaction. What can go wrong? But in fact, if we are doing that, then instead of making our stream shorter and making our issues smaller, then we are just making it bigger. But we don't see that. I mean, not too often. Only from time to time, like Black Friday. So maybe we could store those snapshots in the other stream. That's a tempting idea. But then, what about atomicity? Because majority of event stores that I know grants us the atomicity if we are appending more than one event to the single stream. So at that time, we have the transactional approach, and we are sure that either all of them were appended or neither of them. But when we have two events to the two streams, then in fact, we don't have the atomicity. That doesn't have to be like an issue, but it might be, depending on your use case. So we could store snapshot in some relational database, so the same database that we are using for our read models. We could use some cache like Redis. Everyone loves Redis, especially if you type event sourcing, then you would probably quickly get, besides Kafka, the next thing would be Redis. Or you can use some of your other favorite database that you would like to. However, no matter what database we choose, we will have the same atomicity issue. Of course, that might not be a huge issue, because if we didn't store snapshot, then we would be just loading more events. But then, like Friday, hello. Of course, some event stores like Martin allows you to, like if you are using the relational database underneath, they allow you to store, like you could store in the same transaction, create a unit of work, and store both snapshots and events. But then, you know, we are getting back to the initial issues of double writes. Even though you can, then does it mean that you should? So why snapshots are so popular? So do I want you to tell you that someone is lying on the internet? That's not possible, right? In fact, it is. This is not something that I made. And I was polite enough to not attribute the author of this explanation of the event sourcing. But in fact, majority of explanation why you should use snapshots comes from the fact that at the centerpiece you have the sub-messaging system. It might be Kafka like here, but that applies to any other. If you're using the messaging tooling instead of storing your events somewhere, then you don't have any other option, because you don't have optimistic concurrency, you cannot read from the streams. What you can do is you can just subscribe to the stream. So because you cannot read the events, as I'll explain you at the beginning, then the only option that you have is to store and cache the state somewhere. And because the messaging systems are so popular, and some of them that one was pushing quite of a vision that you can use messaging system as event store, then they become really popular. But still, you cannot treat snapshots as the source of truth, because if you are using messaging system and you are updating, then you have the eventual consistency. And if you don't have guarantee that your storage system will tell you that you made your decision not based on the latest state, then how you can use it on your right model? You don't have any certainty. So snapshots are just cache. And there are two things that are the most hard in the things in the programming. The first one is, of course, naming things, and the other is the cache invalidation. And like I told you, at some point, you will have much bigger traffic, and your cache will invalidate at the most unexpected time. So you can type cache invalidation postmortem in the Google. You will find it a lot of that right after the DNS issues. But coming back to the snapshots, at some point it will invalidate. You cannot treat the snapshots as something that will be always there. Because, for example, you change your aggregate structure, and then you need to adapt your snapshots. And so what you're going to do? Like if you use snapshots because you have too many events, then you have option to, for example, replay all the events, but then you have a lot of them because you didn't care, because you had snapshots, right? Or you can use migrations if you were using the relational database. But in fact, we are then circling back to the issues that we tried to avoid by using event sourcing. So snapshots are great until they are not. So they are like a ticking bomb, like a loan, like a mortgage. At first, you get the boost because you get a lot of money, but then you need to pay it. And you pay it at the end, and usually you will realize that snapshots are not so great at the production. So at the worst time that you can find that out. So what we can do? We can, of course, meet the business. We can do some event storming session, or we can just say, hey, Tom, can we talk? can we discuss whether what I envisioned and how I modeled that in my code is the same as the business workflow works? If we ask enough whys, then we might realize that the vision, this account stream that I show you, is not the one that you should have. That there is something missing there. And what's missing there might be, for example, two small events. One is the accounting mouth close, and the other one is accounting mouth open. Because accounting doesn't work like that, that you keep the record of everything. I mean, you keep it, but to use it for example, current month calculations, you don't need to have all of them. After each period, like 1 year, 1 month, etc., you can just create a summary of what has happened, of what transactions were recorded, and then, based on that, you can open next month. So this information is critical, because those events in the context of the lifetime of our stream is really foundational. They are pivotal events, so they are slicing the life cycle of our operation. So instead of keeping and using for each of our business logic those 20,000 of events, we can cut it and slice it into the manageable length of the streams. And this is not only, someone may think that this is a hack, that we are just, slicing something, but that's precisely how the business works. And this modeling aspect is not only usable in event sourcing, it's also a good practice in general to think about this temporal aspect, because that can help you to make your models smaller, closer to business. So why we don't know about that quite often? Because it appears that for business, those life cycles are obvious. They are so obvious that they are not mentioning that to us. And it's our responsibility to ask our business and dig more and ask enough whys to find out those life cycles. And I can guarantee you that in majority of the business flows that I know, there are such life cycles. So each life cycle will start with the specific event. It doesn't have to be always the same type, but there needs to be some sort of event that gets the initial state of our stream, of the next one. And for all of the streams, besides the one at the bottom, from our current one, we will also have the events that are closing this period of the lifetime of our aggregate. And in fact, if we are doing that, then our aggregate is not anymore account. Our aggregate is account month. So as you can see, this is also reflected in the stream name. So typically, if we didn't have this temporal aspect, then we would have like in event store DB, it is the convention, but in others it's similar. So at first we have the category, for example, account, and then we have ID. And now we are adding additional ID. I call that cycle, but as I said, naming is hard, so if someone has a better name, then please reach me after the talk. But the main case is that we are just adding the temporal aspect and reshaping, like making it smaller. It's also close to what Vladik was explaining on his keynote, that to make something scalable, we need to also make it scalable inside, to make it smaller pieces. But isn't that still too many events? Like here we have 100. But then, remember what I told you, event stores are damn good about reading a lot of events. I'm not sure if code conduct allows me to use them, but let's go. So they are really good at that. And I can tell you, I'm not sure if I should, but I will tell you, the longest stream that I saw was, maybe let's give you the chance to guess. What was the longest stream I saw? How many events it had? Million? 160 millions of events. So people are doing that, and those databases are capable of handling that, but still, like, as I mentioned, just because you can doesn't mean you should. So how to close the book? Like, how to do it practically? How to change, because I show you that you can slice it, but you won't just take the knife and call it a day. So closing the book depends on your specific business use case. So that's, again, something that you should ask your business, how your business works. I mean, maybe you know that already, but still, it's better to ask. So the first potential heuristics is that, for example, you can use it as a separate operation. Because, for example, in accounting, I'm not accountant, but I can imagine that you can have a period that the month is already closed, but you don't have a new one open. And there is someone that needs to do the manual operation to say, OK, we are opening a new one. And for sure, that works in the cashiering domain. Because I don't expect that there are two cashiers sitting at the same chair and just quickly trying to switch the caching drawers. So in fact, there is a period when there is no cashier shift. But then I might be wrong, and maybe accounting month should be closed, and immediately we should open also a new one. Maybe that's the correct thing, especially in your domain. So we can still do batching, of course, depending on the tech that you are using, or if we would like to be sure that this will be automatically handled, then we can, at first, close the accounting month. Then we can have a subscription that is just listening for the accounting month closed event, and then automatically it creates a new stream. But typically, if we start to talking with the people, so that's a warning. If you start talking with them, then it might appear that your use case is much more complicated and much more complex than you thought. But that's also a good thing, right? Because we are getting closer to the business. So if you start talking with your business, then it might appear that you have, in fact, a dedicated process. So instead of just automatically closing and opening new month, then it might appear that there needs to be someone that will approve closing the previous month, that you need to do some reports, that you need to do multiple steps before opening a new one. For example, I was working in the hospitality industry, and there is a really similar process called end-of-day process. And in hotel, at the end of each day, someone has to do a summary and verify, for example, whether all people that should be checked in because they had reservation for that day are in fact checked in, or their reservations were cancelled. Or they need to check that, for example, the guest that had to leave the room or already left the room. So if there are some discrepancies, then people need to check, go to the room, and verify what's happening. So this is really complicated process. And yeah, it might go complex, but of course, you don't simply close the books, right? But it doesn't have to be so complex, because there is a trick. You can still use the single stream. Yeah, I know it's like a, did I just make a joke? And everything that I told you before, it's just a lie, just to trick you? And in fact, it's not. In fact, it's not. Because event stores, in general, allows you to also truncate data or archive data. And what does that mean? We can just say that all of the events that were recorded on this particular stream before a specific position, we don't need them anymore. And we will discuss precisely what it means that we don't need them anymore. So we can mark them as to be deleted. So if we are marking them, then that doesn't mean precisely that we are already deleting them. So then, instead of getting this huge stream, we are getting a manageable small stream with the current set of events that we need for our current business operation, so to make our decisions. So we know those ifs that we have in the code. But then, what's the difference between those events and the snapshot? Because they may look quite similar, right? If we are closing the month, then we should probably put all the summary and all of the information about the account. And if we are opening, then we should put, again, the same set of information. So they are snapshot, but just named differently. Actually, they are not. I mean, there is a risk that they are, but in fact, those events are just representing the specific business operation, the business fact that occurred in our systems. So they are still tightly related to our business process. And snapshots are just the technical, like the name suggests. So they are just the snapshots, the current state at some point of time of our aggregate. So just to give you some code, I'm not sure if on DDD Europe there is an allowance to show code, but nevertheless, this is how the event might look like. So as you can see, they have like the basic stuff like final balance, the total amount of transaction, who approved that, who closed, the initial balance, and that's all. That's all, for example, that we need to start a new accounting month and make our business decision. And snapshots, in fact, are just, our aggregates. So they need to contain all of the possible information that we use. And if we compare them, then it's clearly visible that some data might be the same. Might be that like 90% of the data that you have in your aggregate you should put in the summary event, and that's fine, because events should be as small as possible, but not smaller. So those events are usually, those summary events are usually a bit bigger and contain a bit denormalized data than your regular transactional events, but they are still not snapshots, because they only contain information. The closed event needs to contain all of the facts, like the summary, like a report. Think of it as some kind of report. But for example, we don't need all of the information about all transactions because we don't care. We just need summary. So how to close the books in the single stream? In fact, that's the same case as before. So we can still close accounting month manually and then call another action and then start a new chapter in our lifetime. We can do batch, and in fact, batching is much easier in that case if we need it, because, as I mentioned, atomicity is guaranteed on the single stream. But the same case, we can use the automatic publish, subscribe, run some additional logic, etc. And we can also have the dedicated process. And we can still keep it, this dedicated process in the specific stream to, for example, get the clean history of this process and know precisely what has happened during that time. But if we really want to, then in fact, we could make it yet another slice of our single stream. So it's up to you to decide. It's up to your business and to make the proper alignment and make your decision which strategy will you choose. But that's what I mentioned, that we are truncating data. And I told you at the beginning of the talk that one of the biggest benefits of event sourcing is that you are not losing data. So, in fact, we are not deleting data. If we are marking that as to be deleted, then as I mentioned, it doesn't mean that it will be immediately deleted. And what we need to do is to archive stuff, not to delete it. And archive is different from deletion. This is archive. So you are putting just things that you don't need in some drawer or whatever. This is deletion. So there is a slight difference between them, right? Or to just give you another example, archive is like you are taking your winter clothes. Now we have summer, and you are putting that into closet or the basement. You don't need them for now, but at some point, like next winter, you might need them, so you might need to take them out from your closet or from the basement. And this is deletion. I mean, technically, it's not deletion, because if you think about that, then there is nothing in the word like delete. If we are taking junk and we are throwing it to the trash bin, so does it magically disappear? It's just in the other place right now. So in fact, in the real life, there is nothing like delete. So we should think about what we need, about what data do we need for our current transactional needs, for our operations, and what data we need to just, for example, for read-only. But how to do the archive? And that's quite simple, I mean, in a nutshell. You can, for example, subscribe after you got information that some life cycle was closed. You can subscribe to those events, gather them, and then put it on the truck and take it somewhere else. And what are the strategies and what are the possible places that this truck would take those events? So the first thing is that maybe we don't need, in most of the cases, those events for the transactional operations. Like, for example, if you close the accounting month, then probably, like in 90% of cases, you won't be touching that anymore. But let's say that you have some fraud detection mechanism that will need to run after you close it. So you need to keep it for some time, or you might have some obligation that there is some specific use case that you can reopen this month. So maybe for that case, you can just put it into some other stream. So you would keep the current stream as the current for the current operations, like registering incoming transfer, recording the withdrawals, etc. And you would have the stream with the previous life cycle named with the specific life cycle ID. Or the other case, it's our favorite case, so audit, like a legal audit, that you are obliged to keep those data for 10 years for whatever reason, because some people from government may come to you and ask you to show it. So for that case, we can do the same. So we can either read the events from the old life cycle or subscribe and gather them, and we can put them into some blob storage like disk. Of course, maybe I wouldn't recommend necessarily put it in the disk that is located in some laptop, etc. But probably cloud storage would be much better because it's versioned, etc. It's easier to keep backups. But you get the idea. So if you just needed to show it, then you could put it. It would be much cheaper and much more effective. The other case is that we don't need those events for transactional operation, but we still need to read them. For example, we have some analytics that we need this data to do some calculations, or like, you know, even evil product suggestions on the e-commerce. So for that case, we might just take those events and put them as they are in some other database. Like the databases like Elasticsearch that allows to easy do the transformation filtering is the potential good solution, but we can use whatever we prefer. And what's more, if we need those events for our operations, so for example, we want to still be able to rebuild our projections, so our read models based on those events, then maybe we can put it to some other instance of our favorite event store. And what we're going to get with that is that all of our DevOps processes will be still the same. So we will be using the same tooling. So if we would like to rebuild, for example, read models, then we at first may reprocess those events from this archive cluster, so-called, and then we will be processing those transactional operations. And also we're getting by that this cluster doesn't have to get the sophisticated amount of resources, because we won't be accessing that too often, only in some emergency, like a really important presentation for super important customer, right? So after you did delete archive, then you can delete data. Because, as I mentioned, if we are slicing and decide that we don't need those data, then we are deciding that we don't need them anymore for our operations. But we might still need them, so we should not be deleting them just because. So, but after we move it somewhere, then we can subscribe. Spoiler alert. Yeah. So after that, we can subscribe to the event, for example, that we finished the archive process, and then we can mark those events as deleted. If you are using, for example, event store DB, then you can run the scavenging process that will just clean up your database and from the events that you marked that you don't need anymore. And it's quite often that I hear that people are so afraid that the event store will grow enormously. And it could grow like that, but that might not be an issue if you just use the heuristics and the tactics or strategies that I explained. So yeah, you know that already. So let's just reiterate. Event sourcing is hard to teach, but it's hard to teach because we are using wrong examples. I mean, I was talking with Dan that the bank account is just a good anecdote to just start the discussion, but it's not a great example to explain event sourcing, especially that if you want to convince someone to using event sourcing, because after that you are just immediately getting into the fight and you need to do the jobs, etc. Because people will quickly start asking about, you know, all of the events from the 19 years of my bank account, or they will be asking like about how you make the transaction between two accounts. Again, spoiler alert, it doesn't work like that. There is no transaction between two accounts. So we need to, if you would like to convince someone, then it's better to select something that will allow you to focus on the event sourcing part without getting immediately into all of those considerations. I mean, eventually you will need to reach that, but maybe you don't need to do it at the same time. So if we have such a long stream like the account stream, then event stores are pretty good in handling them. But if you have like 160 million of events, then even event stores won't be a great tool for that. Because that can escalate quickly, because the more they grow, at some level they are manageable. By the way, I'm not sure if you noticed, but those lines in the beginning that you saw are here. So this can quickly escalate. So if someone is saying that, no issue, we'll just use snapshots, then say that this is just a hope-driven design, that it might work for some time, like on your development machine, maybe even on staging environment. But I wouldn't recommend to go with that on production. And in fact, I only know one person, my friend Andrzej, that is happy of using snapshots. The rest of the people that reach production and use them on production, all of them are saying that the operational cost of them is so high that it's just making them unusable. Because snapshots, as I mentioned, they are cache. They might be some pragmatic decision in the transition, like we are doomed, we are already screwed, and we need to quickly optimize our performance because we got into the stage like that. But we should be still thinking about them as some temporary performance optimization, not a solution. And I'm hearing quite often like, Oskar, can you have a look on our design of our event sourcing system? Because we will be storing events and we'll be doing snapshots. And there is like, wait, what? And usually it is like someone is saying that this won't be performant. but what does it mean performant? And usually if you ask that person, then it appears that they don't have any metrics, then don't know, do they need to scale? I mean, maybe you can, you have to, then maybe snapshots would be the solution, but use it cautiously. So, because snapshots are great until they are not, until you learn on the hard way. So I recommend you, if you're using snapshots or planning to use snapshots, before doing that, getting back to your product team, getting back to the business, because you might find out that in your domain, there are life cycles. And I can say you that those life cycles really exist. And when you have those life cycles, then you can slice and make your streams management much more effective and your life easier. You won't be wake up with the cold sweat at night. And you can still use some other tricks, so you can use different tactics or how to close the books. You can use multiple streams, you can use the single stream. I encourage you to play with that and see what's working for you. And what's more, you don't need to use the same strategy for all places. You might use different strategies for different use cases. So search for the life cycle in your model. Because as I mentioned, in really most of the domains that I know, there are those life cycles. I already mentioned the cashier register. Cashier register. So we could keep all of the transaction for the cashier register since it was placed in the department store, but this domain doesn't work like that. You have the cashier shift, and for the operational purposes, you just need the information of what has happened during that shift. Or I already also mentioned the hotel management. You have the end-of-day process when you are making summaries. You are verifying if there are no discrepancies, etc. And you can even have like the patient management. By patient management, this example shows that you don't need, and you should also think about slicing your domain also when you know that it doesn't have huge number of events. Like how many patients could have one doctor? I mean, might be that a lot, but it might be that if you even slice it like per day, so register the appointments for that day, then it still be much closer to the business, and because you will be thinking about the processes instead of the data and the specific state. I'm calling that quite often state obsession. So after we distinguish those life cycles, then we should also think about whether we can or we should or we'd like to archive that. You might not need that because you might not have such amount of data to have the need to archive everything. But if you have that, then it's better to start thinking about in advance. So also the important thing that I would like you to take is to think about the data in the perspective. So what data do we need for our current operational stuff, and what data you need to use for your past, like read models, etc. Because in fact, if you have a look on your data, like even on your aggregates, then it might appear that only a subset of this data is needed to make your business decision. So we also, the thinking about the temporal aspect can also make our business logic and our business model much closer to the business process, and can help us to distinguish that we might don't need some data to run our operations. So the message that I would like to send you at the end is to just keep your streams short, and thank you a lot. It was a pleasure. This was on my bucket list to speak at DDD Europe. So thank you for being here. If you'd like to, you can scan and send me a feedback. But what's more, I'm here till the end of the day. I'm here now. So if you want to just, say that it was okay or that it was terrible, I don't mind. So thank you a lot. And
thank you very much, Oskar.
a moment, selfie.